Yes, you're saying something.
Then there is no write-up in the assignment section.
Just a minute. Yeah, just upload it in the your files. See, go to your T make be DOM 2020. That team. In that team, you have this folder called class materials, right? Inside class material, there is one more folder called lab manual. All of you do this. Are you able to find it?
Sir, the
Yes,
folder
sir.
is empty in files class material.
Yes.
No, in the files, in the class material, not in the. See,
No, sir, it's
go.
there.
It is in this, not in this team. What is it? The lab team, your
Yes,
class
sir.
team.
The
T
simple and
make.
compound pendulum.
Yes, 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 correct. T make B DOM, that one. All of you download that file. That is your write up. And open that document. Hello, Gaurav,
Yes, sir.
you got it?
Yes, sir.
Okay. All right. Now open that lab manual. So this is your lab number 1 for DOM determination. All of you are able to see the PDF on the shared screen.
Yes, sir.
Okay, so this is your today is your first lab session, that is for DOM, that is determination of natural frequency of compound pendulum and find equal length of simple pendulum. All right, so this is your just hold on a minute.
ये आवाज ये नहीं करता स्टूडेंट को बोलता नहीं कि आवाज आ रहा है
नहीं वो मैं पूरा प्रॉब्लम समझा गया।
हाँ,
किसी ने बोला ही नहीं कि सर आपका स्लाइड नहीं दिख रहा है। अभी हम तो इतना टेक्स्ट अभी नहीं है कि मैंने वो शेयर करना भूल गया। मैं मेरे लैपटॉप पे वो चालू कर दिया मैंने स्लाइड शो। पूरा प्रॉब्लम हो गया, उसके बाद में वो बोलता है कि सर आपका स्लाइड नहीं दिख
तो ये बैकग्राउंड नॉइज जो है
रहा। हाँ,
जो म्यूजिक
इट्स क्रिएटिंग अ प्रॉब्लम।
आपको कम आता है क्या?
नहीं नहीं बिल्कुल नहीं, बहुत प्रॉब्लम होता है।
इसके लिए मैं लैब में बैठ के करता हूँ।
हाँ, दैट इज बेटर। लैब में वाईफाई आता है ठीक से?
हाँ, लैब में और हमारा इसमें कौन आता है, लैब में भी आता है
आता है।
मगर अंदर गया तो नहीं आता, मतलब 3 काट गया था।
कहाँ कहाँ अंदर गया है?
उधर वो
लैब में आता है ना?
हाँ, ये लैब में आता है क्या कहना,
ठीक है।
कॉरिडोर में आता
क्योंकि
है।
क्या है, अपना जो पेन है ना वो सब इससे कनेक्ट भी नहीं होता किसी से। वो टैप पेन तो उसका सॉफ्टवेयर इंस्टॉल करना पड़ता है ना कुछ इसमें।
लैब में ये लैपटॉप लेके जाता हूँ।
तो वाईफाई लैपटॉप लेके जाओ तो वाईफाई लगता है। वाईफाई स्ट्रॉन्ग लगता है
हाँ।
तो वहाँ मिलता है। तो ठीक है।
Hello. Gaurav, are you still online?
Yes, sir.
Just hold on a minute. Facing some issues with this PC. Oh, नहीं ना सर नहीं। All right, so this is the experiment. So you are going to calculate the natural frequency of compound pendulum, and your aim is to verify this relation T is equal to twice pi into root of k square plus OG square plus G into OG. All right, so you will just see what is this relationship. Hello, can you hear me, Gaurav?
Yes, sir.
Okay, just yeah. Hello, Gaurav, can you hear me?
Yes, sir.
Hello, hello,
Yes, sir.
Gaurav. Yeah, are you able to hear me? Are you
Yes, sir.
able to see the manual?
Yes, sir.
Lab. Okay. Now this is your first experiment. I hope everybody has downloaded the lab manual. Now we'll start with the experiment. So I will just describe briefly what the experiment is. So today we are going to perform experiment on compound pendulum. So we are going to find the natural frequency of compound pendulum. and we are going to do it by two ways. One is this theoretical relationship which I have on the screen, that is equal to T is equal to twice pi into root of k square plus OG square plus G into OG. Alright, so if you have seen the compound pendulum, I'll just open it. Alright, so here you have a compound pendulum. Are you able to see the screen?
Yes, sir.
Okay, so you have a compound pendulum and it is pivoted at point O. Alright, and G is the centroid. Okay, and for this compound pendulum, K is the radius of gyration. Alright, so for this compound pendulum, we have to prove the relationship that is there in this manual. T is equal to twice pi T is equal to twice pi into root of k square plus OG square divided by G times OG. Alright. So this is the theoretical relationship. This relationship you will get by using here using D'Alembert's principle. Alright. So this is by using your calculus. So after you derive this relationship, now next step is to verify this relationship. So we are going to verify this relationship experimentally. Alright. So for that we are going to conduct the experiment. Now before conducting the experiment, I want all of you have the assignment. You can see the assignment in your team, which is that for that B2 batch. B1 batch T make DOM 2020 B1. In that, go to assignments. Alright, all of you go to TMake DOM 2020 B1. In that you will see one assignment, lab number 1, DOM determination of natural frequency of compound pendulum. Can everybody see it?
No, sir.
No, sir.
Which
No,
team are
sir.
which
Sir,
team
not
are
yet.
No, sir.
The
No,
correct
sir.
channel, but it's not
T,
there.
TMake DOM 2020
Not
B1.
there, sir.
Just refresh it. Just hold on a minute. Gaurav, are you able to see it?
No, sir.
No, sir.
All right, it will get updated in a while. So in the meantime, I want you to do, before doing the actual experiment, I want you to derive this equation for this compound pendulum, that is t is equal to twice pi into root of k square plus og square divided by g times og. Alright. So derive this equation on a piece of paper and upload that as a response to this assignment. As assignment is getting populated, it will take some time. So it is being distributed to the students, it says. So just hold on a minute. So in the meanwhile, you can start with the derivation. Once the derivation is done, you can upload it. Is everybody clear about the task? You are required to derive this equation, that is t is equal to twice pi into root of k square plus og square divided by g times og. Now you should be able to see it. All of you go to the team, make DOM 2020 B1. Are you able to see it now? Gaurav?
Yes, sir.
Yes, sir.
Okay, now you have to submit the derivation of the one which I have just showed on the screen. That is your t is equal to twice pi into root of k square plus og square divided by g times og. Alright. You can use D'Alembert's principle. If you want energy equation, you can use energy equation. Use any method. Write the derivation on a piece of paper. Take a photograph and submit it. So this assign this what you say is practical. It is divided into the rubrics for this practical are in this way. Alright. So 5 marks are for derivation. 5 marks are for theoretical natural frequency. Then equivalent length calculation part A and B 5 marks. 5 marks is for demo and 5 marks is for result conclusion and precaution. Okay. So submit your derivation. I will give you like approximately 5 minutes till 1:45. Upload your assignment as a response to this. Is everybody clear about the task? Sorry for the delay. There was issue with my PC, so I had to change the computer. Is everybody clear what is supposed to be done? Gaurav?
Yes, sir.
Okay. All right, upload your derivations. After that, we'll start with the next part of the experiment. That is, we'll start with the actual experiment. I will be back in one more minute. 1 minute.
Sir, can you give at least till 150 time more 5 minutes?
All right. I hope everybody has uploaded the derivation. Let me just check.
No, sir.
Sir, where to upload?
Sir,
Sir,
2 minutes are more.
Sir, where to upload?
Upload it in the on your Teams. In go to your what do you say assignment.
Sir, image file is fine, right?
Pardon?
An image file is fine, right? We don't have to upload a document now.
No, no, not document. Just a pic your photograph.
All right, sir. Thank you.
Take a picture and Go to T make DOM 2021 B1. All of you have a I have given instruction regarding a string and two masses. You have to keep it ready.
हेलो सर। हेलो
Yes.
सर।
Yeah.
हैंड इन
Go
कर
ahead.
दे कि फिर ऐसे ही रखे? हैंड इन कर देना।
हाँ और क्या करना है? We have to submit it. Hand in, yes, hand in. All right, all of you are able to see the video screen.
Yes, sir.
Okay, now we'll start with the what do you say, the experiment, actual experiment. So what we are now, so this is the theoretical equation. Okay, so now you have a theoretical equation. Now you are going to verify the if you are getting the same value by using an experiment. Okay, you are going to verify it through an experiment. All right. So I will just open the lab manual. Okay, so this is the theoretical equation. This has to be verified experimentally. All right. So in your rough journal, prepare this observation table, all of you. Serial number, all of you are able to see the screen, right? So prepare the observation table. Serial number, OG, number of oscillations, time for n oscillations, natural frequency, experimental, natural frequency, theoretical. All right, so in this we are going to do the theoretical experiment, theoretical natural frequency part now. All right, now I will start with the video. So all of you please pay attention. We are going to take 3 readings. Okay. So this the observation table is for readings. This will you will have in your journal also. Okay. So in that you are going to note all these values. You are going to fill this up. All right. So one by one. Just pay attention. All right. So all of you have noted down the length of the compound pendulum. All of you please note down the length of the compound pendulum, that is 74.5 centimeters. All right. See, all these things you will need for calculations. Huh? Next. All of you are able to see the video, right?
So there's a lot of lag.
Lag is fine. See, you are also, I am also uploaded the video in your class materials folder. So you will get it from there also. But right now, just for the sake of understanding, right? So right now you are not going to measure anything from this video. You are going to measure it where you can either open it at your end or you can download it and you can measure it from there. But the measurements part you should be able to make out. You are able to understand what is being done, right? Gaurav?
Yes, sir.
Okay. So now I'll continue with the experiment. Right. So thickness of the compound pendulum is 2 centimeters. All right. So make a note of that. This you will, all these things you will need for your calculations. This point is the centroid of the compound pendulum. That is your point G. All right. So that in that OG, G is this point. Okay. So this is your first reading. So for first reading, this go to your observation table and all right. So in this OG for the first serial number 1, OG is whatever was mentioned in the video. So make a note of that.
Or it was lagging. Can you show it again?
The video is lagging, sir.
Yes, sir.
This is 34.5 centimeters. All right. So all of you make a note of that. I hope all of you have made a note of it. Even if the video is lagging, my audio is not lagging, right?
No, sir.
Okay. So first reading is OG for first set of reading is 34.5. Okay. Now after that, what we are going to do, we are going to give some oscillations for this arrangement, and we are going to measure the time for 10 oscillations. Now this part of the experiment, you have to do it at your end by accessing your video. Okay. So don't worry about it now. Just try to understand what is to be done now. What is to be done at this moment. Right. So in this way you have to measure for first reading, you have to measure the time for 10 oscillation. Okay. Now we are going to suspend the compound pendulum from the second slot. All right. All right. So for second one, the distance from OG is 14.5 centimeters. All of you note that down. All right. So that will be the second reading in the observation table. All right. So second OG. Okay. Again, now this is the second OG. And so two readings are done. All right. Now this is the last reading. Okay. Now for the last reading, we are going to invert the position and then again repeat the same procedure. Right, so for the third reading again, OG is 14.5.
Sir, what did you select? Could you repeat the reading again?
So third OG is 14.5. All right, so all of you note that down. Okay, now we'll continue with the remaining experiment. All right, so that is as far as the demonstration is concerned, that is that's all. Now we will go for the calculations. Okay. Now in this calculation, first you have to calculate the theoretical natural frequency. So theoretical natural frequency, how will you calculate? You will calculate by using this equation. All right, that is equal to T is equal to twice pi into root of k square plus OG square plus G into OG. Now OG you will get it from this table. All right. Okay. Now you have to find out k square. So what is k square in this case? K square is nothing but your radius of gyration. Okay. Now experimental natural frequency, how will you get? See, you are going to measure time for 10 oscillations. Then divide the total time by 10. That is number of oscillation is 10. Okay, that will give you time for one oscillation. Take a reciprocal of that. That will give you the natural frequency experimentally. All right. Is that clear to all? Any questions, Gaurav? How to
No, sir.
calculate experimental natural frequency? Okay, so that you have to do it from the video. That you can download it at your end and you can do it at your end. Okay, so that part we'll come back to it later. Now here you start calculating with the theoretical natural frequency, and that is given by twice pi into root of k square plus og square divided by g into og. All right. Now here you have to find out k. Okay. So the next task is, before calculating k, again write on a piece of paper that the expression for k square. How will you calculate k square? Based upon whatever measurements you have done so far, write it on a piece of paper. How will you calculate k square? And again take a picture and upload the response in the same assignment. you are allowed to upload multiple files for the same assignment. So again do the derivation and find out the expression for k square. All right, so you have to find out the expression for k square or k. And upload it. I will give you 5 more minutes to find out the value of k.
Sir, where to upload it?
So where to upload exactly, because I think I uploaded my earlier PDF in the assignment section, in the experiment section.
How to operate that, because I am pressing number log and pressing also then also numbers come up.
So
I don't know which.
Alright, all of you have uploaded.
Sir, where to upload it?
Upload it as an additional. Add one more file to the one which you have just now uploaded, na. Do the same assignment. Add one more file.
Sir, we have to calculate the values or just
No,
derive the
just the
equation for k.
expression. Just the expression. If you have calculated it, that is also fine. You will anyway need to calculate it.
We undo turn in no first, then
Yes, undo turn it and then again turn it. All right, so I will just discuss how we get this radius of gyration. So mi of the rod is mi of the rod is ml square plus v square by 12. This is the expression, okay? And equivalent mi will be mk square. So equate both these values. So you will get k square is equal to L square plus b square by 12. So you have calculated the length of the rod and the width of the rod. Alright. So substitute that value and get the value of k square and convert it into appropriate units and get the, go to your observation table. Okay, fill in all the data that you can calculate at this moment. You cannot calculate for this time period for oscillations, that is this and the time period for, that is n oscillation and experimental time and experimental natural frequency. These three columns, that is column number 4th, 5th, 6th, you cannot calculate. You can calculate the 7th column, that is natural frequency theoretical. Alright, so here you can substitute the value of k square in this expression. You know OG from this observation table, write all the values and find the natural frequency and uh, enter the values, again take a snap of it and submit it. Alright, so this calculation of natural frequency, that will have 5 marks along with the derivation of radius of gyration. Okay, so both the things you submit it together. Is there any question? Are there any questions?
Hello, sir. Hello, sir.
Yes.
Sir, once I hand in one photo now, then
Huh?
if I want to hand in another photo, that for that I have to undo the hand in and then only the option shows add work.
Yes, yes, that is how we have to do it.
Okay, sir.
Okay. Is the next part of the experiment clear to all? What calculations you have to do? Alright, so first part was the derivation, second part was the expression for radius of gyration, that is k square is equal to L square plus b square by 12, and third part you have to fill in this observation table except the 4th, 5th and 6th column. Serial number, OG, number of oscillations you can, number of oscillations you can also leave, That also you can do OG and the last column, natural frequency theoretical, using this expression. Is everybody clear how to calculate natural frequency theoretical? Gaurav?
Yes, sir.
Okay. So calculate that, and so take the photo for,
Sir,
yes,
in radius of gyration, what you have to take LNB, that 74.5 into.
yes, but you have to convert it into appropriate units. Huh? Those were
Okay, okay.
in centimeters. So everything
So
has
we
to
want in na millimeter.
no, everything has to be in MKS.
Okay, meter. Okay, sir.
All right, I will give you uh, till 225 to complete all the calculations and upload it.
Sir? Sir?
So do we need to even upload the theoretical working?
Or done with the calculations?
Sir, do we even have to upload the working?
No,
Or only
sir.
the Sir, do we have to upload the
Sir, do we
working as
have
well?
to upload the working?
Hello.
Sir, do we have to upload the working or would only the table do?
Hello. Yes. I did not hear you.
No, sir, I was asking that do we need to even upload the working or would
Yes, you
the
have to
table
upload
do?
the rough work.
Rough work as well? Okay, sir.
Yes. Okay, students can continue with the calculations. In the meanwhile, just put your calculations on hold. In the meanwhile, we'll go to the next part of the experiment. Now you have your radius of gyration. You have found the theoretical time using this expression. Now we'll go to the second part of the experiment, that is the equivalent length. Okay, so you have to find the equivalent simple pendulum, equivalent length of the simple pendulum. So what does that mean? You have to replace the compound pendulum with the simple pendulum so that it will give you the same amount number of oscillation or same natural frequency. All right. So the equation for time period for simple pendulum is t is equal to twice pi into root of L by g. Now make two observation tables. One is for so you have two masses, right? One is a small mass, one is a large mass, or you can call it as mass A and mass B. Not necessary. One might be large, one might be small, in any order. Okay. Now for simple pendulum, the time period, the expression for time period is twice pi into root of L by g. Now for this t here, take this t from your compound pendulum. Alright, that is the theoretical time. That is reciprocal of natural frequency. It will give you the theoretical time, and using that, substitute the value of that t in this expression. Alright, so only unknown in this case is L. Alright, so find L for the corresponding time from the compound pendulum. So you will get here three values of L. Alright, one for three observation, you will get three values of L. Two might be same because the compound pendulum is symmetrical and we have taken it reading by turning it around. So you might get this two values as same. Alright, but theoretically you should get three values of L. Okay. Now for these three values of L, set this length in your simple pendulum. Alright, and give it 10 oscillations. Then divide the time by number of oscillations, that is 10. That will give you time for 1 oscillations. Okay, and compare it with the theoretical time that you have got from the compound pendulum. Okay. So theoretical time for serial number 1, 2, 3, A and B will be corresponding time will be same for the same equivalent length. All right. Now for that part, yes.
So what about the mass of the ball?
mass, see, for mass you can take any mass. So that part you have to do it. I have told you to get one string and two masses, right? And a stopwatch. That message was passed on the group, right? Gaurav?
Sir, mass we can bring anything, but we don't know the weight mass
You
of
don't need
the
the
object. For example, if we take any
you don't need
bottle or pen, then what is the mass we cannot know, na?
that is not required. See, what is the aim of this experiment? See, you are going to take some mass in A part and some mass in B part. Okay, and you are going to, for serial number 1, 2 and 3, the corresponding equivalent lengths are going to be same. Alright. So irrespective of varying the mass, you should get the same time for 1, 2 and 3. Alright. So 1, 2 and 3 time for A and and corresponding 1, 2, 3 time of B should be same. Why it should be same? Just look at this equation for the time period. It has no mass in it. Alright. So the time period is independent of mass. Alright, so you do not need the weight, only thing you need to do is vary the mass. For A section, you can have some mass, for B section, the mass should be different, that's all. Now go ahead and ask your question.
Sir,
Huh?
just to confirm,
Huh?
we take the theoretical values from the compound pendulum, we
Yes,
substitute it in 1 upon 2 pi root over L by G, we find out the value of L in centimeter,
yes,
then we make the simple pendulum with that value of L as length, and after that
yes,
we find out the experimental values, right?
yes.
Okay.
Okay. Now, if you are find the first thing is find the equivalent length, and once you are done, one by one we'll do the demo part. Demo of the experiment has 5 marks. So for demo, you have to switch on your camera and do the show me how you are going to take the reading for part A, serial number 1. Okay, so you have to tell me what is the equivalent length and measure the time for 10 oscillations. That will be your experiment. Okay, so who is ready with the demo? Can start. You have to switch on your camera and do the demo on screen. Now for this, I want 4 students to do the demo simultaneously. So any 4 students who are ready can start. Demo part has 5 marks. I will give you a few minutes to get ready because this batch has more students. B1 has only 20 odd students. This has only, I think, how much? Let's take the attendance also. 49 students. If you have any questions regarding what is to be done, please ask me. I hope everything is clear. Yes, I'll give you a couple of minutes to be ready, and then we'll start with the demonstration. You have till 3:10 to complete the demonstration. Those who are not completing the demonstration, for them the mark will be 0. All right, ready with the demo? Yes, anybody? Or everybody wants 0 marks? Hello, Gaurav?
Yes, sir.
Yes, ready with the demo?
Yes, sir. I have calculated the equivalent length.
Huh?
It's come out to be 48 centimeter. I have
Okay.
tied the string to a pen,
Just
and
switch on the
I'm
camera.
giving the oscillation for 10 seconds.
Hello, can you switch on the camera? Hello, Gaurav.
Can you see me?
Yes, yes.
So I have to set the timer for 10 seconds. Then I have to see how many oscillation it has done, and then the calculations.
That way also, but it is very easier for you to calculate time for 10 oscillations. That will be easier for you. Because how will you calculate, how will you measure half oscillation or 3/4 oscillation? So better measure time for 10 oscillations and approximate the time.
Okay.
Timer is more accurate, na? In seconds you have, right? In your stopwatch.
Okay.
Ah,
Okay.
you can start with the demo.
So the length has to be 74.4 with any length do.
No, no, no. For what?
So for that simple pendulum thing.
Yes. Just somebody has a mic on at the background. Yeah, yeah. Go ahead. What we are asking?
No, sir, I was asking that for the simple pendulum experiment, do we have to take the length as 74.5 in our demo, or would any length do?
74.5 is what?
So, sir, so that's what we are asking, sir, for the experiment purpose, would any length do, or do we need to specifically take
No, no, no. What is
74.5?
74.5? First you answer that one.
So, length for the compound pendulum, the point from
Length
the,
for the compound pendulum means what?
the vertical length.
So that is for what purpose? What is the purpose of that length?
So, nothing in compound pendulum. I mean, it's just for measurement of k, value of k, radius of gyration.
So then once you measure the radius of gyration, what is that used for? Who is the student? What is the name?
Sidama.
Sriram. Gaurav, you are done. You can
Yes.
continue with the remaining experiment offline.
Okay.
You're done. Okay. How much time did you get, Gaurav?
14.27 seconds for 10 oscillations.
Okay, okay. All right. So rest of the experiment you have to complete it offline. Huh? I will just mark it. All right. So I marked the demo for Gaurav. Anybody else ready with the demo?
Sir, I'm ready.
Go ahead. Switch on the camera. See, time for your demo only will be till 3:10. Huh? That is the cutoff time. After that, it will
So,
not be.
this is the string, and I've tied it to a rubber band.
How much
Rubber
length?
eraser. Length is 17 centimeter.
How did you get 17?
So
Uh,
I measured it with the scale.
no, no, but how did you get 17 for which is for which reading? First or second?
First,
And what was the time period for first one?
so I'm doing it.
No, how will you? You cannot just take equivalent length like that. No, you must have got it by calculation. No?
No, sir.
Then
Okay,
what?
then I'll check it again. Wait.
Yes. Next student. If anything is not clear, you ask. If any part you are doing is not clear to you, you should ask. Yes, anybody else ready with the demo? Only one student?
Sir, I am ready.
Ah, who is that?
Sir, I am Tusha Patil.
Switch on the camera.
Am I visible?
Yes.
So, sir, we have
First, how much length you are taking?
47.8 centimeter, and so this is the string. I mean, this is my mask suspended.
No. See now you're suspending the mass.
Yeah.
See, it is also oscillating. Okay.
Yes.
So the mass should be a small mass. Okay. Now it becomes a 2 degree of freedom system.
Okay.
Sir,
Change the mass.
Okay, I'm changing.
Yes. Next.
yes, sir.
Yes.
Am I visible, sir?
Yes. Yes.
Yeah, sir. So the mass at the end that I chose was a bottle cap because
Ah.
it was somewhat light, and the the length I got for the first reading was 47.9 centimeters.
Okay. All right.
And
Start. Yeah. Go ahead with the demonstration.
yes, just a second. I'll set up the stopwatch.
Okay. When you give the oscillations, don't give very high degree of oscillations. Give
Yes,
oscillations
sir.
to a very small degree.
Yes, sir.
Otherwise, your readings will be your calculations will be wrong.
Yes.
Yeah, go ahead.
Okay, just a second. So it came out to be around 16.
Okay. All right. You're done. The rest of the experiment for the remaining 5 readings, you can do it offline.
All right, sir.
Okay.
So, I am ready with my mask.
Yes.
Uh, so, can you?
Yeah. Yes. Yes. Go ahead. How much length did you?
So this is the small mass I took, and
Ah,
the length for the equivalent length is 47.8 centimeter,
okay.
and I am taking a calculation for 10 oscillations.
Okay.
One,
Sir, we don't have a string.
Okay. Then you don't
the
give the demo.
calculation timing comes out to be 14.5 seconds.
Okay. All right. You're done. The rest of the experiment you completed offline. All right. Next student. Yes.
Sir, my equivalent length is 47.8 for the first experiment.
Who is the student?
Nishida Mehta, cap ID 70.
Okay.
Sir, I've taken the bottle.
Just a minute. Just.
I've
Okay.
taken, uh, 10
Okay. What is the equivalent length?
47.8.
Okay.
Sir, 14.77 is the time.
Okay. Just Nishita Mehta. No?
Yeah.
Sir.
Just a minute. Just.
Yes, sir.
Sir, third number, Nishida Mehta.
Excuse me, sir.
Just a minute.
हमें पता नहीं चला. सर तो चल रहा हूँ. मेरा बच्चा नहीं बैठा. हेलो.
Nishita Mehta, you're done. Next students.
Sir, okay. Sir, I have equivalent length for the second is
Shubh
40
Shetty, no? Move back. I cannot see the
of
pendulum.
the second is
I
46.
can just see your face, Shubh Shetty. I cannot see the demonstration. Just
Sir,
move back.
sir, this is the 46.2 centimeter.
Okay.
Okay, sir, I am going to.
Okay. Yeah, go ahead.
It is 13.37.
Shubh Shetty, no?
Yes, sir.
13 point.
37.
Okay. Rest of the experiment, do it offline.
Okay, thank you.
Sir, I'm ready. Can I do it?
Yes.
So even I'm ready. Should I continue?
Yes, yes.
Sir, I'm also ready. I can also
Sir,
do.
even I am also ready.
For
Sir,
the
even
length,
I am also ready.
Wait, one by one.
Sir, even I am also ready.
Sri
sir,
Rama
the
Singh.
Sir,
length.
even I am also.
I'll
अरे एक
call
मिनट
the
बोलने
name.
दो.
I'll call the name. That only that student do the demo. Sri Rama Singh.
Yes, sir. So the length I got is 47.87 centimeter, and I've tied a bottle of Vicks along with it. So I'm just going to take the reading right now. So should I start?
Yes, start.
Can I start?
Wait.
So the reading I got is 13.76 seconds.
Okay. Rest of the experiment you completed offline. Meet Patel, go ahead.
It is weight. Equivalent length is 32 centimeter.
32 centimeters. This reading. How much did you get time? Hello. 32 centimeters. There is something wrong. You check your calculation. Hardik Jain, go ahead.
Yeah, so I've got the length as 47.8 centimeter. And so I'm starting it. So this is my eraser. So I got the timing as 13.8 seconds.
Okay. Yeah. Rishabh Vora.
Sir, sir, I have this string
No.
and
See,
a pen
don't
cap.
attach this kind of mass. See, the mass is also wobbling, so that becomes like a multi-degree, 2-degree freedom system. So you have
Sir,
to have
this,
something very
sir,
small.
I'm taking a pen.
The pen mass. The pen is also independently oscillating, right? It should not oscillate independently. It's a small mass you take, like a yes. Trisha Rane 116. Yes, Trisha Rane, only you unmute your mic. Huh?
Yes,
Unmute your
sir.
mic. Rest of the students keep your mic at mute. Go ahead. Yeah, go ahead with the demonstration, Trisha Rane.
Yes, sir. 14 seconds.
And equivalent length is?
48 centimeter.
Okay. Yeah, rest you do it offline.
Hello, sir.
Just a minute. Rane, it is done.
I do it now.
Yes.
Hello.
Yeah, who is showing? Meet Patel.
Yes, sir. Sir,
What is
I calculated time for oscillation. I got 12.3 seconds and
no,
the
no,
length
what is the equivalent length you got?
got 45.
45. Okay. And time is
12.3.
okay.
12.3.
Okay. Okay. Rest of it you do it offline.
Sir,
Yes, sir.
Sir,
Sir,
Hello,
sir, I'm
sir.
getting a net setup. Just wait.
Sir.
Hello, sir.
Sir,
Huh?
Sir, can I do it?
Who is doing Rishabh Bora? Yeah, go ahead.
yes,
Paksha,
sir.
Harsha. Okay.
Sir, I am starting the stopwatch now.
No, no, just show me that pendulum you are using.
Sir, this.
You're again using a pen.
No, sir, this is a steel means buckle.
Just move it back. I cannot see it. Okay. All right.
Sir,
Go
I am
ahead.
starting the stopwatch.
What is the equivalent length?
Sir, equivalent I got 48 and
Okay.
time is 13.6.
Okay. All right.
Last roll number
Okay.
6005198014.
Time, how much you got?
14.2 seconds.
Okay. All right. Next student.
Sir, can I do it now?
Sir. Sir, can I do it?
Yes. Prapti Vora, go ahead.
Hello, sir.
Ah,
Yeah, I've got the length of 47.6 centimeters and I'm starting the stopwatch now.
okay.
So it's 14.2 seconds.
Okay.
Hello,
Sir, could I show it now?
Sir, I can do it.
Rest you
Sir,
can.
can I show you now, sir?
Can I start now?
Yes, sir, it is.
Hello. Sir,
Hello, sir.
Who is ready?
Sir,
sir, Smith,
Prapti.
sir. Smith.
Sir, me.
Smith Kotari, go ahead.
yes, sir. I have taken this charger, and my equivalent length is 47.6 centimeters.
Okay.
Hello,
Yeah, yeah. Okay, go ahead and do the demo.
and my time is 14.878 seconds, sir.
No, you have to do the experiment in front of me.
Sir, I did it. Sir, I will do again. Sir,
Yes, how much is the time?
14.5 seconds, sir.
Okay. What is the
Sir, can
name?
I do?
sir,
Smith
could I do it
Kotari.
now?
so can I do it next?
Just
Stop,
a
Sir,
stop.
minute.
can I do show?
no, sir.
Sir,
Hello,
can I
sir.
do it now?
Hello, hold on a
Vakshal.
minute.
Sir, I'm
Sir, can I do?
So
Hold
can
on.
you take 3, 4 people at the same time? It will be
No,
Yes,
no,
faster.
no. It is
Yes,
not.
sir. Can you take three,
It
four
is
people
not
at a time?
possible.
Sir, can I do it now? Sir, I'm
Wait
ready.
a minute.
Hello, sir.
Ah, yes.
Can
Sir,
I do
can
it?
I do now?
11. Go ahead.
Yes, sir. Sir, I
Prakash.
calculated the equivalent
Sir,
length.
who?
It comes around 46.7 centimeter. So should I start my
Yes, Jainam.
oscillation?
Yeah. Yeah, go ahead.
Yeah, 1 second. So it came around 13.8 seconds.
Okay. Rest of it you can do offline.
Sir,
Okay,
Next
can
sir.
I
one.
do it
sir,
now,
can
sir?
Sir,
I do it?
Jainam Shah,
So
sir.
can I do it next?
Jainam
Sir,
Sagar.
Sir, can I do
Sir,
it
now
now?
can
Yes.
I do it, sir?
Sir,
Smith
can I do
Angara.
it now?
Yes, sir.
Yeah. Unmute your mic. Hello, Smith Angara. Unmute your mic.
So I have suspended this charger from the string. The length came out to be 48.2 centimeters. Sir, I'll start the stopwatch, sir.
Okay.
Sir, it's 14.2, sir.
Okay. Rest you can do it offline.
Sir, can I
Okay.
try now?
Sir, can I do it now, sir?
Can I do it now,
Please,
sir?
sir.
Sir, can
Priti
I do
Yadav,
it
go ahead.
now?
I will call the name. Just you keep your hand raised. I will call the name. That person should unmute the mouse and do the demonstration. It's 102.
Yeah, sir, so I have taken a battery and a ribbon, and the equivalent length is 47.4. So I'll start this stopwatch.
Okay.
So it's coming 13.9 seconds.
13.9.
9.
Okay. Yeah. You can do the rest of the experiment offline.
Okay.
Sir, can I do it now?
Who's that? Prakshal Shah?
Sir, can I do?
Oh, yeah.
Yes,
Prakshal
sir.
Shah, go ahead.
Yes,
Sir,
sir.
can I do it?
Sir, I have taken a charger and I have tried it to a ribbon. So the equivalent length is 47 centimeters. Sir, I am starting a stopwatch now.
Mhm.
Sir, it came 14.23 seconds.
Okay. Shubh Shah.
Thank you, sir.
Can I go next?
Shubh
Yes,
Shah.
sir.
Sir, can we leave the meeting now?
Yes, those who are done can leave the meeting.
Thank you, sir.
Sir, yes, the string and I have tied the weight. I'm just starting. In the length is 47.8.
Hmm.
Sir, can I start the stopwatch?
Yes. Yes.
Sir, just a minute. My weight. Just a minute, sir.
So can I do now?
Yeah, go ahead.
Sir, can I do it now?
Yeah.
Now?
Sir,
Parth,
hello.
Sir,
Parth
can I do
Amal.
it?
Sir, can I do it?
Hello, sir. Hello, sir. Hello.
Parth Amal, switch on the camera. Unmute your mic.
Hello, sir. I have attached a pen stop to the string, and my equivalent length is 47.82, and I'm starting the stopwatch now. Sir, it's 13.25. The time is coming around 13.25 seconds.
Okay.
So may I go next?
Can I do
So
now,
can
sir?
I do it next?
Can I?
Sir, can I
Sir,
do it? Can I do it next?
Can I go next?
Neeraj,
Sir, can I? Sir, can I do it again? Sir, can I try now?
Yes, sir, can I try?
Sanjeev
Sir?
Sriram.
Yes, sir. Sir, so effective length I've gotten is 47.8,
Okay.
and I'm starting the timer right now.
Okay.
Sir, I got 13.47 seconds.
Okay. Rest you can do it offline.
Yes, sir. Thank you.
sir.
Next
Sir,
student.
can I go next?
Again now?
Sir,
Sir,
can I
can
do
I
it
go?
now?
Sir, can I go next?
Sir,
Can I
Shubh
do
Shah.
it
Sir, I
again?
am
Sir, can you just before I run?
yes, sir.
Shubh Shah, go ahead.
Sir. Sir, I tied a rubber and the string length is 47.8. So I'm starting the stopwatch. Sir, the time is 14.2.
Okay. All right. Rest you do
Sir,
it
can I
offline.
do now, sir? Sir, can I do
May I go next?
Can I go
Sir,
next?
may I go next?
Sir, can I do it?
now, sir?
Sir, can I go next?
Sir, can I go next?
Sir, can I go now?
Sir, can I go now?
Yes, sir, yes. Neeraj, sir, Neeraj.
Yeah, don't. Otherwise, I will stop the demonstration. Rest of you will get 0 mark. I have told you, you just keep your hand rest. Don't no talk in between. Otherwise, whatever students are remaining, I will straight away give 0 marks. Yes, unmute your mic, Neeraj.
Yes, sir. So it's 13.8.
What is the
My
equivalent
effective
length?
length was 47.2.
Okay.
Yes, thank you.
Rest completed offline.
Okay, sir.
Srivardhan Suryavanshi.
Sir, by when do we have to submit these values and the experiment?
Till next turn.
So,
Okay, sir.
so I have this
Okay.
mass and
So,
effective length
the
is.
last student. Hello. Srivardhan Suryavanshi, this will be the last students for the as far as the demo is concerned. The rest of the students who are not given demo do not have to worry. They can give the demo to, during the next practical. All right. Now, is there any question regarding how to complete the write-up? Are all the parts of the experiment clear? Okay, go ahead, Srivardhan Suryavanshi.
So whatever we have submitted until now, do we have to undo the handle or do we have to keep it as it is? Because we have submitted the derivation.
Yeah, you can undo the
Undo,
handle.
no?
Yeah.
Okay, sir.
So effective length is 48.3 centimeter, and I have this mass. So I'll start the stopwatch now.
Okay.
So these values and calculations you have to submit by when?
Next turn.
Okay, sir. Thank you.
Sir, so the time was 14.3 seconds.
Okay. All right. So we'll stop for today. I have already taken the attendance. So
Thank you, sir.
we'll complete the lab manual
Hello,
and
sir.
and submit it. You can see whatever you know how to do the experiment, right? So do the experiment offline. See what you have to do. You have to take the printout of the lab manual and fill in all the data by hand. All the calculations are to be filled by hand. If you are confident about your calculations, you can directly fill it by pen. So, or if you're not confident, fill it by pencil and then later make it fair. Okay. So by the next turn, you can submit the entire write-up along with the derivations and rough calculations by next turn. That is today is 15th. So your next practical will be on 22nd, I guess.
Sir, do we have to show the rough work on printout?
Not on printout, just attach in an additional document. Attach the printout and also attach the derivations and also attach the rough calculations. So by
So,
22, everything should be there.
sir, for compound pendulum, the column which are not filled today are kept blank now.
No. See, so what for that part? See, I have showed you how to take the readings, right? Now, if you go to your the T Make B DOM 2020, go to that lab videos folder. Okay, in that it says lab number 1 compound pendulum. Okay, so you can download the video, and since there was a lag in when I give the demonstration of the experiment online, there is a lag. So, but when you download the video and when you see the video, you will the measurements are at real time. So either you can use the timeline on the video or you can use a stopwatch to determine the times, and then you can fill the remaining columns. All right. The remaining columns in table number, that is for the compound pendulum, that is number of oscillations, time for n oscillations, time per oscillations. So experimental natural frequency, all these columns you will be able to fill from that video. Is that clear?
Okay, sir.
Huh? All right. Okay. So we'll stop for today.